Row transformation. Row transformation is nothing but the operation of rows. For example, interchanging the rows, multiplying row by some constant k, or subtracting one row from another row. So these operations are called as elementary row transformations. Now these transformations are denoted as if we consider interchanging row, then if we have to interchange first row and second row, then we denote it as R1 2. It means we are going to interchange row first and second. For example, if we consider matrix A as 1 12 24 34 0 2 3, consider matrix A, and we apply the row transformation R1 2, then this matrix will be, after applying row transformation, that is R1 2, it will be 0 2 3 12 24 34 4 3 2. This is an example of row transformation. If we want to apply the column transformation, similarly, it is denoted as C12, and after applying column transformation C12 on matrix A, then matrix A will be, after applying C12, it will be matrix A is equal to, it's equivalent to 24 2 3 12 0 4 34 3 2. That is, we interchange the first and second column. So in this way, row transformation and column transformations are applied on the matrices. Now we are going to study the inverse of matrix by using row transformation and column transformation. Now let's find the inverse of matrix by using reduction method. Reduction method means by using the row transformation or column transformation. That is, we know that A into A inverse is equal to identity. Then by applying row transformation on A and I, we are going to, as we know that A into A inverse is equal to identity, then we are going to apply row transformation or column transformation in such a way that A transform into the I, that is identity matrix, and I transform into another matrix, say here B. Then our equation becomes I into A inverse is equal to B. And as we know that I is multiplicative identity in matrices, therefore I into A inverse is A inverse, which is equal to B. So in such a way, we are going to find out the inverse of matrix, that is A inverse is equal to matrix B, which is obtained by applying row transformation or column transformation on the identity matrix. For example, here consider matrix A as 2 1 5 3. Then first of all, we have to check whether the matrix is singular matrix or non-singular matrix. For this, we have to find the determinant of A. So let's find determinant of A. It is equal to determinant of 2 1 5 3, which is equal to 2 into 3 minus 5 into 1. It is 3 into 2 is 6, minus 5 into 1 is 5. So it is 1. As it's not equal to 0, matrix A is non-singular matrix. And hence A inverse exists. Now we have to find the A inverse. We know that A into A inverse is identity matrix. Now we are going to apply the row transformations on A and I, so that A transform into the identity matrix. Now here value of A is 2, 1, 5, 3. A inverse as it is, then I is identity matrix of order 2. It's 1, 0, 0, 1. Now we have to convert this matrix A into the identity matrix. For this, we have to convert this entry into entry in the first column in first row, that is 2. We have to convert it into the 1 into 1. For this, we are going to interchanging the first row and second row. So it is after interchanging the first and second row, the matrix will be, we have to interchange the rows of identity matrix. So it is 0, 1, 1, 0. So after interchanging the rows, the equation becomes like this. Then after this, we have to convert this 3 into 0. After this, we have to convert this 2 into 0. For this, we are going to apply row transformation as R2 minus 2 R1. Then first row is as it is, that is 1, 3. Now second row, R2 minus 2 R1. Therefore 2 minus 2 into R1 is 1. So it will be 2 minus 2 R1 is 0. So its entry will be 0. After that, R2 minus 2 R2, here it is 5 minus 2 into 3. So 5 minus 6, which is equal to minus 1. So A inverse as it is. After this, first row as it is. Second row is 1, 0. For this entry, it is equal to 1 minus 2 R1. 2 R1, value of R1 is 0. So 1 minus 2 into 0. So it is 1. And 0 minus 2 into 1. It is equal to minus 2. Comes like that. After this, we are going to convert this 3 into 0 and minus 1 into 1. Now we have to convert this 3 into 0. For this, we are going to apply R1 plus 3 R2. So we get R1 changes to R1 plus 3 R2. That is 1 plus 3 into R2 is 0. So here 1. Then 3 plus 3 into minus 1. So it will be 0. So 0. A inverse as it is equal to 0 plus 3, 3 into 1, it's 3, and 1 plus 3 into minus 2, it is 1 plus 3 into minus 2. 3 into minus 2 is minus 6 plus 1 minus 5. These are the rough calculations. So second row as it is. Now after this, we have to convert this minus 1 into 1. For this, multiply second row by minus 1. Then we get first row is as it is. 0 into minus 1 is 0. Minus 1 into minus 1 is 1. A inverse as it is into first row is as it is. Minus 1 into 1 is minus 1. Minus 1 into minus 2 is 2. So this is nothing but the identity matrix of order 2. So identity into A inverse is equal to 3 minus 5 minus 1, 2. Therefore, A inverse is equal to 3 minus 1, 5, minus 5, 2. This is the inverse of matrix A. And this method is called as reduction method. And this is the inverse of matrices by using reduction method.